Okay, so calculus. Who can tell me what calculus is all about? Excellent. All my teaching is done.
Differentiation.
Differentiation, yeah. So we are going to differentiate stuff. But what does differentiating do for us? Why would we want to differentiate something?
I was just
What's the link to stuff? What, like, why do we differentiate? What are we talking about? Yeah?
finding radius on a graph where it's gradient changes.
Good. We're finding gradients. So if we're differentiating stuff, we're finding gradients of the function. Yes? Officially, we're finding the gradient of the tangent to the curve at that particular point, but enables us to find the gradient. Okay? So that's an important thing that you are aware of and try and keep in the back of your mind the whole time. Who can tell me the rule to differentiate? So that's how we show it's the gradient, dy over dx, but what's the actual rule? How do we differentiate something? Casey?
You subtract one from the exponent and add that to the front, like add the coefficient.
Be careful that it's actually you move the power first. So the power becomes a constant first. You multiply by the power, and then you subtract one from it. Don't use your new power to multiply. Okay. So for example, well actually we may as well use this one as the example. So we've got a negative power, so you just have to be careful when we have to do this one. So our power comes to the front. So this would be what? Negative 3x to the negative 4, because taking 1 from negative 3 makes it negative 4. Yeah? Mm-hmm. Right, so as you may or may not recall, we finished this lesson at the last lesson by trying to remember what happens when we have things written as a fraction. So when they're written as a fraction, we can't differentiate them. Okay, so what we have to do is change this so we no longer have something less you something over something. Okay? I'm just going to write equals because I haven't differentiated anything yet. This statement is equal to it. Now I think Leonie finishes off with this one. So Leonie, what was it? Good. X to the power of negative 4. Do we all recall that?
Yeah.
Oh, Brianna. Is that just because it's Wednesday morning, or we didn't remember that? We just had a bad day. Okay. Anything I can do? Right, so when it's power 4 becomes negative 4. Now, actually, let's do all of these first. So y equals 1 over x squared. Kiara, what would that one be?
X negative 2.
Good. Ooh, next one. Lily, what would this one be?
Oh, I don't know.
Give it a bash. When you're in an exam, you're under pressure, you've got to try and think what you might do. What do we need to move?
The x3.
Yeah, so where do you think it's going to go?
So like.
Yeah, so what will we write?
For x.
Yeah, okay. See? You can do it. Because obviously here we had a 1 on top, so we could have written the secret one. We could have written the secret one, but we don't need to. Okay, so that's why we didn't write it. But if there is a 4 there already, then the 4 will stay there. Okay, now this one is a little trickier. Oh, Gabrielle. No, but that's what most people would write. Jamie? Nope, not 3, it's negative 1. DNA.
Is it 3? It's negative 1 and x to negative?
It could be, but we probably wouldn't write it like that. Kiara?
Is it brackets 3x and then the negative 2 and the alpha?
No, that would be if there was a bracket down here. This one, secretly, the only thing we need to move is this x. Okay, so it would actually be 1/3 x to the negative 2, which why, Leonie, what you said was also correct, because 1/3 could be written as 3 to the negative 2, okay, but we would just leave it as 1/3. You happy with that? Well, happy as in understand it?
No.
So if you have something like that, so you've got more than one thing on the bottom, it's actually only x that we need to move. Now, the thing that Kiara said was if it was written like this, then it would be 3x to the -2. But that's only if the whole thing was in brackets. Yes? We see the difference between that one and that one, don't we? Yes, Miss Harris. Right, so now we've written them with our powers, we can now differentiate. So, Dinah, what's the first one? Why an air? Yeah. Right, Dinah, what's this one?
4x
Careful.
-4x minus 5.
Good go. Yeah. Oh. Let's see. Sabrina, what's this one? Power comes in front, take one off the power.
-2x to the power of -3.
Yeah. Shayla.
-12x minus
Nice. Elena.
Is it 2
Almost.
negative
Lovely.
to the power of -2.
Lovely. Okay. Did someone say why?
I don't understand.
Which bit?
All of it.
Oh, shush now. From the beginning?
Yeah.
You did one.
Yeah, that's
That's totally hilarious. Right. So our power is -4. So this now becomes the number in front of the x. So we write -4 lots of x. And we remove 1 from the power. So -4 taken away 1 becomes -5. So this derivative is -4x to -5.
Okay.
Did I say that badly?
No, I'm fine. I'm good.
You're wondering where it all comes from?
Yeah, why do you take 1 away from the power?
Just that's the rule.
Okay. Okay.
I'm going to go with that. Okay.
Okay.
So the rule is power comes in front, take 1 off the power. That's what you do all the time.
And then you multiply the power and the number in front if you're
Yeah, if there's something already there, you would just multiply those two numbers together.
Okay.
Yeah?
Yeah.
I mean, it didn't help because I think you came in late last session after the dentist, so
Yeah.
no, you're not after the
Yeah.
exam. Dentist? Just make up stuff. Right, okay, done. We did that. Okay, Lesbians? Okay.
I don't know.
So we're starting to get a little bit. No, it's fine. It's fine. So,
Radius.
no. So remember, function notation doesn't have to be F. It could be any letter, G, P, Q, whatever. Okay, so this is just in that other format. Remember? So essentially, yeah, that's why. But if it's written in function notation, remember we wouldn't write dy dx equals. What would we write to show that we're differentiating it? Elena?
G -1.
You got mixed up when I shouldn't have mentioned it because now you're thinking that. If that's the one it's not. That's the inverse function. What was it? It's not -1, it's it's an apostrophe. Okay? So when we're differentiating it, when it starts off looking like this, we would show we're differentiating by writing G dash x. But our issue is that we've got a fraction involved first. So our first step is not to differentiate straight away. I'm going to keep it as gx. My x cubed is still fine as it is, but I need to rewrite this one because it looks like those ones we've just been doing. So Emma, how am I going to rewrite that plus 3 over x squared?
You would put negative, just 3
What sign goes into it?
plus.
Yeah.
3
Yeah.
x minus 2.
Good go. Okay, so I've rewritten my question, my first step. Now I can differentiate it. Okay, So now I would write g dash x. And I follow my rule. I think that's quite good dash. Emily, what's the first tab?
3x 2.
So part 2, good. And the next one, Lily.
Negative 5 or 6.
Which one is it?
5. No, it's on 7.
With multiplying, remember?
6.
Yeah.
I guess. Negative 3.
Good.
Is that plus 3?
No, that totally says minus 6x and negative 3, but no surprise. All being weird. Emma. I don't know. I don't know. Let's just not talk about it.
Why?
Hurts my little heart. Why?
No.
I'm with you. We have to ask me a question though.
I don't know how to.
So the power came in front.
Oh, even for that one?
Everything. That's all, always.
Oh, I
Forever, ever,
thought it
amen.
was
No, forever, ever, amen. No, that's just the format. Okay, that's just showing us that we've differentiated it. Because sometimes things are written y equals, sometimes they're written fx or gx or hx, whatever. So it's just the way we write it. It's a different name for it. Your Emily, she's Kiara, it's just the way we do it. It's a different way of writing it. Yeah? Right, okay, so we seem to have gone off on a tangent a little bit. Some people are chatting away. So, first step, we have to look at the question, do we need to do anything with this function first? And if we do, why? So, Gabrielle said we do because there's a fraction going on here. Yes? So, we need to rewrite this first. So, I'm going to write gx again. Remember, I'm not going to show that I'm differentiating yet. And I'm going to keep everything the same, apart from this term here. Casey, how am I going to rewrite this bad boy?
I'm going to is it 3 over 2 x squared?
Nearly. It was squared on the bottom, so it can't be squared when we move it. What happens with this one? Yeah. It's going to become negative.
Why is it? I mean, 2. So I wrote it as -6.
Now so the thing that people often do once we get to these kinds of questions is they start mixing up, differentiating and rewriting stuff. Okay? So you've got to be really careful that our first step is literally just rewriting it. So as we did in the previous page, when you have a number on the bottom as well, that number stays there, so that stays as 3 over 2, and the x squared is the only thing that's going to become negative. Now we can differentiate. Okay? So that was just our first rewriting step. So now we write g dash x. So Shayla, what's our first term?
6x.
Nice. Sabri, what's our next one?
2
Careful.
minus 2x.
Yep. Mia, next one.
0.
Yep, so this, remember, because it's got no x attached to it, we ignore that. Do you want to write plus 0 so you can see that later? Sorry, I'm in your way. And the last one. Do you know?
Maybe negative 3x
Oh wait, because oh no. Would it be positive 3?
Yes. Now, what made you say that?
Oh, because I brought the negative 2 exponent to the front and then multiplied it by the fraction. So 2 times 3 over 2 is 6. Actually, no, it's not. It's it. No, it's not. Wait. Wait. I don't know. Well, anyway. And then the negatives cancel out. So then, actually, the 2's cancel out too. So that would be 3.
So I'm actually going to go in slower steps. I'm going to write 6 over 2. Which is what you had. Right, I know you had the right answer, and I'm sorry, I just got excited. And then I'm going to write x to the negative 3. Now, does everyone see where I got plus 6 over 2? Yes? No? Anyone not? Katie's face tells me not.
Is that going to multiply them?
Yes, so I had negative 2 multiplied by negative 3 over 2.
Okay.
And remember that when we're multiplying fractions, top times top, bottom times bottom, and 2 whole ones is 2 over 1.
Okay.
Yeah. I'm then going to simplify this, tidy it up a little bit, so I wouldn't keep my 0, so I've got 6x squared minus 2x plus 3x to the negative 3. Because 6 over 2 is a 3. Okay? Can I go too fast? Right, I'll top. Right, now this one here. We've got 2 things on the top, 1 thing on the bottom. If we have this kind of situation, what we would do is we would separate these. So this question, it's not called anything, let's call it y. And so y, I'm going to now write as 6x squared over 3x, take away 9x to the 4 over 3x. So all I've done is separate my fraction. Now we can do that because we know that both of these 2 things have this as its denominator. Because if we had this statement here, the red one, we would simplify it to give us the one above. Yes? So that means that we can work the other way as well. You all happy with that step? Yeah? So then, obviously looking at this term here, I've got things that cancel out. So I've got 6 and 3, so they cancel each other out. So that becomes now 2, and that becomes a 1. Because 6 divided by 3 is 2, yes? And 3 goes into 6 twice, or 3 goes into 3 once. But I've also got x squared divided by x. What happens when we are dividing terms with the same base? It's simplified. How do we simplify it? We're dividing. Emily? You subtract the indices. So there's a secret 1 here, yes? So I've got x squared over x to the 1, which just leaves me with x. So I've now got 2x. Like that. This is still 1. And we're going to do a similar thing now with the other term. So we've got 9 and 3. So this becomes 3 and 1. And again, we've got x to the 4 over x to the secret 1, which would be x to the 3. So we've got take away 3x to the power of 3. Yeah. So that work is just simplifying it. We haven't even started differentiating it. Okay? But the differentiating process we know is straightforward. But we have to have it as simple as possible before we start differentiating. So, if we've got, so because it's a y, we write now dy dx equals to show that we're differentiating it. Brianna, do you remember what's 2x? What does that differentiate to give? No? Does anyone else remember when there's just an x attached to it? Elena?
The
just for 2.
Good, yeah, it just goes to 2. So when there's just an x, no powers at all, it will always just be its coefficient. Okay, so that one becomes 2. And then we're taking away 3x cubed, so 3. What's this one going to be?
Negative 9x.
Good. Okay, done, finished. Yeah. So the hardest stuff here was the simplified before we could actually get going. Okay? So the process itself is generally okay. Here. Now, we talked about not being able to differentiate when things are in fractions. It's going to be a similar situation when we see these root signs. Okay, so you also need to remember your rules when it comes to changing square roots or any root. Now this is a big fat 4, it's not the 4th root. Okay, so how would I change the square root of x? I know this was a bugbear and people were not great at remembering this. You know?
Would it be x to the power of 1?
Remember, this is a big 4, it's not the 4th root. No? Casey?
Is there that squared and then the other x squared?
No. Emily?
Is it a fraction?
It is a fraction. Well, what fraction? If it's the square root. 3?
X to the power of 1 over 2.
Good, x to the power 1 over 2, because it's a secret 2 there. So this would be 4x to the power of 1/2. Okay? So had it been a baby 4 DNA, that's why I thought you were going to just go, oh, then it's just 1 over 2 then. So had it been, for example, the cube root of something, then that would be x to the 1/3. Okay? So that's stuff you need to remember as well. That's completely separate. So big 4, x to the power 1/2 plus x. Oh, let's call this y as well. Okay, so we've rewritten it, now we can differentiate it. So now we show the dy dx. And this is where your skills at multiplying fractions and dealing with fractions comes in. So you're going to do 1/2 multiplied by 4. 2. Yeah, you all happy with that? Do I need to write it? Should I write this? I don't know. What do you want me to write? Oh, shush now. Should I just write 2? Will you all know how we got that? Okay. Now, here's your tricky thing. You've got 1/2 and you are subtracting 1. So what's 1/2? Subtract 1 whole 1. Okay. Negative 1/2, yeah. So we've got 2x to the negative 1/2. And then we've got an x. What did we say about when there's just an x? It becomes just the, not 0, just the coefficient of it, which there is a secret 1 there. Yes, so this would be a plus 1.
Would you ever write like 2x negative 0.5 into the power of 0.5? Or they prefer if you do
They prefer to keep it as fractions. Yeah. I mean, I can't. They shouldn't mark it wrong because that's right, but I've never seen it as a decimal. So that's that question finished. Okay.